Hi, my name is Ray Peeney, and I'm here to talk to you about EMF and our solution for coding DLCs on Chalcogenides. EMF is part of the Dynasil family of companies. It is a pioneer in thin film coatings, and we've been in operation since 1936. We're a demonstrated leader in optical coating solutions, and we have an incredible engineering and design team to help you overcome your toughest optical coating challenges. We can do large format coatings up to 108 inches, and we have two ITAR and ISO 9001 certified facilities, one in Rochester, New York, and the other in Ithaca, New York. When we talk about infrared optics, they are used in some of the harshest environments known. Everything from being on the front of a car to allow for driver vision enhancement, into the defense world, where they're sitting as windows and cameras looking for threats to our warfighters, in terms of search and rescue underneath the helicopters, or even as handheld or helmet-mounted firefighting cameras. They need incredible protection and are able to, we need to withstand some of the harshest environments in the world. Diamond-like carbon-coated optics are an excellent solution for these real-world issues. They have a very high hardness, a lot of abrasion resistance, meaning that you can attempt to scratch the window and it will not damage the window. They're also highly resistant to corrosion and chemicals, and most importantly, they're optically transmitted in the infrared. Diamond-like carbon is a mixture of the graphite and the diamond forms of carbon, and basically it's like a thin layer of diamonds coating your optic. It's very good at protecting most infrared surfaces, including germanium, zinc, selenide, silicon, zinc sulfide, fused silica, and chalcogenide glasses. It's got anti-reflective coating properties, and we can adjust it for different spectral ranges. As I said, DLCs work on a number of different infrared optical materials, and depending on the wavelength range or the type of system that you're looking at, you may choose one or more of these materials to go into your optical system. And EMF can help coat all of these different optics and optical materials. We have a number of different infrared coating options, depending on the material and the wavelength range that you're looking at. All of these can pass the various different environmental tests, which we all do in-house. So it makes it very, very easy for us to coat and then check the coatings to make sure they're adhering and passing all the environmental tests. So as I mentioned, we're definitely talking about chalcogenide glasses, and this is a whole family of different glasses sold under many different trade names, but they all have some chalcogen in there, either selenium or tellurium or sulfur. And as you can see, there are many different trade names, from Schott, Vitron, Amorphous Materials, Lightpath, and they have different wavelength ranges and responses. And our coating process is able to coat all of these different types of glasses. When in terms of a diamond-like coating, it's actually two coatings. One is a diamond-like coating that goes on the exterior side of the lens, and the other side has a high-efficiency anti-reflection coating. As you can see, the reflectance from the DLC is a little bit higher, but in combination together, they provide a great anti-reflection as well as protective coating for the optic. As far as transmission, we typically are at 90% throughout the entire wavelength range. Here you can see two curves, one for germanium and one for chalcogenide. This includes both the DLC and AR coating, as well as the material transmissiveness. In coating optics, there are usually four different coating issues that are fairly common. One is pinholes, which are small little holes within the coating. Another is stress, where the chemical bonds within the coating are creating a stress between the different molecules and can actually crack and destroy the coating. Non-uniformity is where the coating is not the same thickness throughout and causes different effects. And finally, adhesion is probably the most difficult issue, and this is where you actually have problems keeping the material and the coating sticking to one another. EMF has designed a custom DLC coating chamber to produce DLC coatings. We use proprietary plasma-enhanced chemical vapor deposition technology. It's fully automated. It has a circular geometry to improve uniformity. We coat up, which is unique in the industry, meaning that any excess material falls down away from the optics rather than on top of the optics, which reduces the number of pinholes. And we've done advanced process control on the cooling and the positions of the gas inputs and outputs, all leading to a superior coating. So with our custom design DLC, we have virtually no pinholes, and our circular geometry and coating up technique increase the uniformity of the coating throughout the entire optic. In terms of stress and adhesion, we have strict process control, special tooling that's designed specifically for our chamber, and a proprietary cleaning technique that leads to overall better performance of the coating. Diamond-like carbon is just one of the services we offer. We have diamond-like carbon coatings, anti-reflection coatings, cold mirrors, hot mirrors, front surface metallic mirrors, oleophobic and hydrophobic coatings, and we coat plastic as well. Make sure you talk to us about the EMF Edge in terms of on-time delivery, product quality, and detailed technical solution support. We can coat on plastic, glass, metal, and ceramics, and have the capability of doing everything from prototypes to very high volume, and can handle very large optics, including astronomical mirrors. Thank you for your time, and if you have any questions or would like to know more about our capabilities, please reach out to EMF, and we'll be happy to answer all of your questions.